Hello everyone, in this lesson we're going to learn about different segment relationships in circles. This is lesson 10.6, so like the other ones we've got some different theorems and then we'll do some examples. So the first one, theorem 10.6a, is called the segments of chords theorem. So this says that if two chords intersect on the interior of a circle, then so let's think about what we learned yesterday. We learned about the angle. So this angle would be 1/2 of the sum of the arcs that it intersects. But now we're going to be talking about what the actual segment lengths are. So the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments in the other chord. So here, if you have, for simplicity's sake, let's call AEA, AB, EB, B, and we'll call this segment here X and this segment here Y. So if you have that, then you know that A times B, the product of the lengths of the segments in one chord, so A times B equals X times Y, the product of the lengths of the other chord. All right, so the next one is about just vocabulary in this case. So a secant segment, that's a new term. Secant segment is a segment that contains a chord of a circle. So you know a tangent segment is a tangent, but it just has a point outside of the circle and then a point on the circle. A secant segment is kind of like that. So this whole entire thing is the secant segment, and then just the outer part is the external segment. How do you know it's a secant segment? Because it goes through the circle, not just touching the circle like a tangent does. Okay, so this is the external segment. Okay, we're going to use that concept in the next theorems. So theorem 10.6b says segments of secant's theorem. So this says if two secant segments, so AB, EB, and ED, share the same endpoint outside of a circle, then the product, this is very particular, so be careful. The product of the length of one segment, so the whole thing, and its external segment. So we're going to take the entire segment and multiply it by just the external segment. So we'll call this part A and we'll call this part B, and then we'll call this part X and we'll call this part Y. So equals the product of the lengths of the other secant segment and external segment. So they're saying that EA, the outer part, times the whole thing, EB, which is also A plus B, equals EC times ED. So another way we could write this is that EA, which we're calling little a, times the whole thing, which is A plus B, is equal to, which just means that it should be proportional to EC, which is X, times X plus Y, the whole entire secant segment. All right, the next theorem is really similar to that, but you've got a secant segment and then a tangent segment. So this says if a secant segment and a tangent segment share an endpoint outside of the circle, so that part, is important. You got to have that part. You learned that on your last quiz. Then the product, again, of the lengths of the secant segment and its external segment, so the same thing, EC times the whole thing, the outside times the whole thing, equals the square of the lengths of the tangent segment. So EA, you're squaring it. And that's because there's no outside part and inside part. It's just all on the outside. So you take that and then just multiply it by itself, which is squaring it. Okay, so if we let this be X and maybe this is part is A and the internal part is B, then we would say X squared equals the outer part times the sum of the whole thing. All right, so those are our three theorems. Let's do some examples. So here find ML and JK. So what we would do here is the theorem where you do this times that equals this times that. So we'll do x plus 2 times x plus 1 equals x times x plus 4. All right, so here we would need a FOIL. So we would do x squared plus 2x. Plus x plus 2x gives us 3x. And then the last would be 2. And then here we'll just distribute. So this would be x squared plus 4x. And thank goodness the x squares cancel. And if I subtract 3x onto the 4x, I just get that 2 equals x. Now that's great, but they asked us to find what ML and JK are. So ML and JK are not going to be congruent. They would only be congruent if they were both diameters. And we're also not saying that these are bisectors. Clearly, these are not bisectors. Okay, this would be a bisector if it was a diameter, but we don't know if it is. All right, so let's plug 2 back into the expressions. So this is 2 plus 2, which is 4. This is 2 plus 1, which is 3. So ML is 7. And then JK, this is 2. And over here, this is 2 plus 4, which is 6. So JK is 8. So see, not the same. All right, here find the value of x. This is theorem 10.6b. This was theorem 10.6a. So if we wanted to find the value of x, let's just set up an equation here. So we'll do the outside part, 5, times the whole thing, which would be x plus 5, equals 6, times the whole thing, which we could just add those two numbers up, so that would be 15. All right, go ahead and distribute the 5, if you wanted to, you could divide it by the 15, but if you don't want to, that's okay. And then 6 times 15 is 90. Subtract 25. You get 5x is 65. Divide by 5. And I think that's 13. Wait, did I do something wrong here? No, I don't think so. I think we're good. So what's 65 divided by? Pretty sure it's 13. Yes. Okay. And then they just said to find the value of x, so that would be your answer. All right, for this one, this is like the other one, 10.6a. So you do 3 times x equals 4 times 6, which is 24. So that would give you 8. All right, this is the Secant Segment Theorem 10.6b. So we're going to take 3, the outside part, and multiply it by the whole thing, which would be x plus 2 plus 3, which is x plus 5. And then x plus 1 times the whole thing. I'm kind of running out of room here. So you've got x plus 1 plus x minus 1. When you add those two things together, you're just going to get 2x because the ones will cancel. All right, so here just use a distributive property on both sides. We'll do 3x plus 15 equals, distribute the 2x into x and 1. That'd be 2x squared, and then plus 2x. So the thing is here that the x squares are not going to cancel, so we are going to have a quadratic equation. I'm going to show you how to do this on your calculator. So the one thing you will need to do, though, is to get everything to one side of the equation. So I'm going to subtract the 3x and the 15 over. So we would get 2x squared, and then minus x, and minus 15. Okay, you could factor this if you wanted to. It's definitely factorable. I don't know how many of you learned AC method with factoring last year. But if not, let me show you how to do it on your calculator. So there's a button if you go into apps, and then you scroll down I think it's polysim 2. So if you do, it's polynomial simulation, I think, but it's solving quadratic equation. Polynomial root finder, that's what we want, option 1. And then the order, that just means 2, that means it's n x squared. That means it's a quadratic, so we want that. We want real numbers. We don't want to get imaginary answers. So just make sure all of these are the same, and then you would click next. In order to click the next button, you would click on graph. Okay, and then you're going to type in your polynomial. So the coefficient here is 2. So I'm going to press 2, enter, and then this is a minus sign. And then that's just 1. We don't want to leave it as 0 because that would mean that there is no x term, but it's 1 in this case. This is a minus. This is 15. And then we're going to click solve. So to click solve, you would press the graph button. So the solutions are -5/2 and 3. That's how you solve a polynomial on your graphing calculator, and if you don't want to factor it. Because this is like 2x, so this isn't like an easier one to factor. So our answers then for x equals -5/2 and x equals 3. But can we have -5/2? No, because if we were to plug it into one of these, we would get a negative answer. So x equals 3 is going to be our solution. All right. For this one, for number 5, we would do 16 squared. Actually, I'm going to do this part first. I'm going to do x times x plus 8 equals 16 squared. Okay, distribute the x, and then subtract the 16 squared over, which I think is 256, to get one side equal to 0. Now with this one, you could factor it. It would be x minus 16 times x minus 16. Well, actually, hold on a second. Would that work? No, that wouldn't even work, because -16, that wouldn't work. What are other factors of 16? Let's try just doing the other one. So if you can't figure out how to factor, you can figure out what factors of 256 are that add up to 8. But if you don't feel like thinking about that, use the polynomial root finder. So remember, it's in apps. If you want to write the steps down in your notes, that might be a good idea. So go to apps. Actually, from here, you're going to have to press second quit first, and then second quit again. So apps, and then polynomial root finder, or polysim 2, which you could just click the 9. Polynomial root finder, enter. So this is all the same. So you could just click next. And then here, the coefficient of x squared is just 1. And then this is plus 8. It's plus 8. And this is minus, so press enter if you don't need to change it. And then 256. Enter. Okay, and then press solve by pressing graph. Whoa, okay, so kind of crazy answers there. I'm not sure. I feel like we did this right. I don't know what they expected us to have our answers as. I don't remember what it was in the book. And for some reason, I don't have it written down here. But anyways, so what is this number here? This number is 108,809 divided by 8710. So obviously, I don't want to write that down as my answer. I want to figure out what the decimal version of that is. So I'm going to press second quit, and I'm just going to type this in, not using the fraction button. 809 divided by 8710, and then that'll give me a decimal. So 12.49. 12.49. I'll have to double check what the book says about that question. Okay, and then last one here, which I promise does not involve quadratic formula or quadratic equation. So find the value of x. So this is the same thing. We're going to do 5 times the whole thing 5 plus x, or x plus 5, and then equals 7 squared, which is 49. Distribute the 5, you get 5x plus 25 equals 49. Subtract the 25 over, and you get 24 divided by 5, and you get 4.8. Okay, so you will get more practice using the polynomial root finder in your Edulastic, because I do want you to learn how to use that. So other than that, though, that's the end of our examples, so I hope you guys have a great day.